So to solve this log equations, notice that on these equations you have one logarithm, one number, right? For all of these that look like this, every time you have a logarithm on one side of the equal sign and a number on the other, or some quantity on the other side, what you're going to do is you're going to convert this into an exponential function. All right, so to do that, if you remember, this 7 right here is the base of my exponential function. And you're going to switch that x and that 2. So this is going to be 7 squared is equal to x. And obviously 7 squared is 49. So that's it. That's it for that one. Okay, does that make sense how that's working? So on the very next one is the same thing. If you have that, if you already have one logarithm and one number on the other side, you're going to do the same thing. Now this one's going to require a little bit more work. Remember, this right here is the base of your exponent. Okay, and then now you're going to switch the 27 to 3 halves. So this is going to be x to the power of 3 halves is equal to 27. Now this one is going to require a little bit of work on your part to try to solve this. All right, so then the question is, how do I get rid of this 3 halves power? You remember? Yeah, we're going to raise both sides to the 2/3 power. All right, so I'm going to come to this side and raise that to the 2/3 power, which is the reciprocal. I'm going to raise this to the 2/3 power. Alright, so this part right here, remember when you have a power to a power, you multiply. And if you multiply 3 halves and 2/3, you get 1. So this is going to cancel completely out. So you have x. And then now, if you have a calculator, you can do that with a calculator. But remember, this is the same thing as having the cube root. Remember, the bottom number is a root. So this is the cube root of 27. And then you're going to square that. And again, you could do that with the calculator if you wanted to. All right, the cube root of 27 is 3. And then 3 squared is 9. So this is x is equal to 9. Okay, so that is that. Now in the next part, same thing. We're going to start off by rewriting this as an exponent. So this is going to be x to the 0 power is equal to 2. Remember, this becomes the base of my exponent, and we're going to switch that 0 and that 2. Okay? Now, but we know that x to the 0 number is going to be what? 1. So we have 1 is equal to 2, which is not true. Okay? Now, assuming that x is not a 0, but so this is going to be no solution. All right, so we have no solution for that. So as you can tell, they're relatively easy, right? Now, on the example, last example on this page, same thing. We have a logarithm, we have an x on the other side, or some quantity. We're going to rewrite this as an exponent. So this is going to be as the base to the x power is equal to 64. And then now on this one, it's like the ones we did previously when I would say 2 to the what power is 64, right? So then you have to kind of either use your calculator or kind of do it in your head. 2 to the 4th power is 16, 2 to the 5th power is 32, so 2 to the 6th power should be 64. Right, so again, 2 to the 6th power is 64, which means that x is 6. Does that make sense? So it starts off pretty easy, right? No big deal. Now let's go to the back. And so far we haven't even used the rules that we talked about yesterday. All right, so let's go to the back here. Try to at least rewrite me, or try to solve this if you can, all right? So if you're watching this on video, go ahead and fast forward. But I'm going to give you just like a minute. Try to see if you can figure out that one. Just rewrite it and solve it. It's actually not that hard. So rewrite that as an exponential function. That's step number 1. Actually, I can even tell you what the solution is. So if you're actually doing this, you want to know if you did it right or not. That's the solution you should get. All right, so let me just take a quick look at what you're doing. Anything. But remember, you have to write it as an exponential function, just like I did in the first 4 examples. Oh, wait, 2 to the 4th power is 16, so we want to move on after that. Write it as an exponential. This becomes the base of your exponent. Switch that and that. 2 to the 4th is 16. Very good. 2 to the 4th is 16. Okay. So let me go back to this. So I think so far for what I saw, it was going pretty well. Again, remember this becomes the base of your exponent. So we have 2, and then we're going to switch this to quantity. So this is 2 to the 4th power is equal to x minus 9. Now 2 to the 4th power is 16. And then we add 9 to both sides and we get 25. All right, so that's pretty much the end of the examples that we have that I feel are relatively simple. Okay. All right, let's go to problem number 6. Wait till I'm done with the notes. All right, so number 6, notice that on this one, my goal is, all right, if you have a logarithm and you have other stuff on here, your goal is to try to get this logarithm by itself. So then the question, don't worry about the fact that it's a logarithm. It doesn't matter. If I'm trying to get this logarithm by itself, what should I do first?
Minus 17.
Well, minus 15, right? Oh, I see. You added those two, right? Remember, this 2 is attached to the logarithm, right? So, and that's actually a very common mistake. Remember that 2 is attached to the logarithm, so I can't just add those 2 together. All right, so I'm going to start off by subtracting 15 from each side. So now I have 2 log base 2 of x is equal to 10. All right, what else do you want to do? How do I get rid of that 2? Right, so in this one you have 2 choices. All right, you can do what Robert said, which is you can bring this 2 up as a power, okay, or you can divide by 2. All right, I choose to divide by 2, but the way that you were going to do it, it would work out the same. We should have the same answer. All right, so if I divide this by 2, I'm going to divide this by 2 also. So I have log base 2 of x is equal to 5. So notice where I got to. Now I have one logarithm here, and I have a number here. Then it becomes like the problems we have done previously. All right, so now we're going to rewrite this to, remember that becomes the base of your exponent, and you're going to switch that 5 and that x. So we have 2 to the 5th power is equal to x. And then after that, you have to just plug in 2 to the 5th power in your calculator or do it in your head, either one. And the answer should be 32. Is that making sense so far? Okay. But again, let me just say that again one more time. If you did it the way that you were talking about, it would work out the same. Okay, you would get the same answer. All right, on number 7, all right, a little bit more difficult. Now, the reason this is more difficult is because you have more than one logarithm. You have a logarithm here and you have another logarithm here. So in order to do that problem, what you must do is you must get all the logarithms on one side of the equal sign and all the numbers that are by themselves on the other side of the equal sign. All right, so my first step should be to add 2 to each side, and simultaneously I'm going to add the log base 8 of x to both sides. Okay, now I'm going to rewrite it. So I have log base 8 of 4 plus log base 8 of x is equal to positive 2. Are you with me? So remember, my goal is to try to get this logarithm from 2 logarithms and to one of them. I want to have one logarithm on one side, the number on the other. Okay? So what that means is that I'm going to have to use those laws of logarithms that I used in that previous lesson to figure that out, right? So how can I combine these two logarithms into one? Do you remember? I heard a whisper of multiply. Right. We're going to multiply that 4 and that x together. So we have 4x is equal to 2. All right, so now we're relying on those rules, those laws that we learned yesterday, the laws of logarithms. All right? And now that I have one logarithm, one number, I can actually solve this. All right, so we have this 8 becomes the base of the exponent, and this is going to be to the second power is equal to 4x. All right, remember that we write 8, and then we switch that 2 and that 4x. So that 2 becomes the power, that 4x goes over here. Don't forget that. Some of you did forget that on the quiz yesterday. So 64 is equal to 4x. And then after that, you solve, divide by 4, and you're done. So x should be 16. All right. Now on the last one, same idea. All right, it looks, for some people it's confusing, but it's the same idea. What you must do is try to get all the logarithms on one side of the equal sign and the numbers on the other. Now don't be confused. This minus 2 is not attached to this 8. So these two are not attached. All right, so what I'm going to do is I'm going to add the 2 to the other side, and I'm going to subtract this one to the other side. All right. So again, I'm doing that so I can get all the logarithms on one side. So I have 2 log base 4 of 8 minus 2 log base 4 of x is equal to 2. All right, so before you try to use the laws of logarithms, all right, you have to get rid of this 2 and you have to get rid of that 2. Okay, so again, you have two choices. All right, you can either, on this one in particular, you can actually divide both sides by 2, because see, this is a 2, that's a 2, and that's a 2, right? So I can actually divide both sides by 2, or I can bring them up as a power. And I'm going to bring them up as a power only to show you that it does work. All right, so again, the laws of logarithm says that I can bring this up as a power. So this is going to be log base 4 of 8 squared minus log base 4 of x squared is equal to 2. So this is log base 4 of 64 minus log base 4 of x squared is equal to 2. So again, remember, now I can use that rule that says that if I subtract, I can actually divide those two quantities. So this is, I'm going to combine, I'm going to condense this into one logarithm by doing this. Alright, so again, if you were asleep or not paying attention or were not here yesterday, this part right here is a part that's new, the step between here and here. Alright, once you get to that point, then it becomes a lot easier because it becomes like the first 5 examples that we did on here. This 4 becomes the base of your exponent, that 2 becomes the power, and I'm just going to rewrite that, 64 over x squared. Now I need to solve for that. 16 is equal to 64 over x squared, like that. And then now, you must be able to solve this. So if you ever see this, this tends to cause some confusion in some of you because you have that x squared on the bottom, so you don't know how to bring that to the top. If you have a fraction here and a number, it's okay. Just put this number over 1, cross multiply, is the same thing. Alright, or you can just multiply both sides times x squared. Either one, but I like to do it like this because you just come out of geometry, well, almost a year ago now. But you did this quite a bit, where you cross multiply and divide it over and over and over. Alright, so this will be 16x squared is equal to 64 divided by 16. So this is x squared is equal to 4. And now we're going to take the square root of 4. What's the square root of 4?
2.
Kind of. Plus or minus 2. Alright, don't forget they have a plus or minus, but
It's also just like factoring.
yeah, it's like factoring in a way. Yeah, you could have factored this if you wanted to. You could have subtracted the 4 and done the difference of squares. Having said that, alright, you cannot have a negative logarithm. Remember what we talked about, right? Yesterday you saw that in the homework if you did it. So this negative 2 actually does not count. You can't use -2, so the only answer you have is the +2. Okay? So that's pretty much it for that. Now let me actually show you so the first page of the homework is fast, right? You're just rewriting everything down and then solving. But I want to make sure that you know what you're doing, if what you're doing is right or wrong. So I'm going to show you just the answers to homework 53. All right, so I'm going to move this. So here are the answers, all right? So make sure you copy those down. And if you're watching this on video, just do what you have to. Just fast forward, do whatever. All right, so those are the first 4 answers. Let me move this a little bit. So if I'm going too fast, please let me know. You good? All right. I'm going to go ahead and move this around. Now on the back, we have 1. And by the way, I'm going to come back and talk about this one in just a second, all right? So don't try to copy all this down yet. So we have a 1, we have a 5, we got a 16, we got a 36. For 15, which I feel is the hardest problem on here, the answer is 8. That's 12. And we got 16, 2, 20, and 7/2. So again, the answer for this one's just 8. Okay, so don't worry about the work up there. I'm going to go back to that problem in just a second and explain it. Okay, so before I talk this problem, which is problem number 15 on the homework, please don't, a lot of you see a problem like this and you're like, oh crap, all of the problems are going to be exactly like this. That's going to be really hard. There is only 1 or 2 problems like this. Actually, I think this is the only problem that's that hard on there. Alright, so calm down. So in this one right here, and I'm going to put it up again, so if I'm going through it pretty fast, then don't worry about it. I'm going to stop the video and just put a picture of it. Yes, Austin. Yeah. Alright, so anyway, so in this part right here, remember I want to get all the logarithms on one side, right? So what happened between here and here is that I subtracted this and I subtracted that. So that's how I got to that point. Getting all the logarithms on one side, the number on the other. Alright, after that, remember, there's nothing else I can do besides doing the law of logarithms that says that if I subtract, I can divide. Okay? Now I have 1 logarithm and I have 1 number on the other side, so I can do the rules, I need to transform this into an exponent. Remember, that's 6 to the -1 power is equal to that. Now 6 to the -1 power is 1/6, and to go from here to that step, I did what I told you I did on the last one, cross multiply. 1 times this is just itself, 6 times all of this, which I actually wrote here, is that, and after that you just solve for x. Alright, so again, if you're watching that and you're like, man, that looks tough. It is, but we only have one of these problems, okay? Let's see if there's anything else I need to tell you. Alright, again, if you got any questions, please let me know. Quiz them.